Hi, welcome to my video on proving trig identities, number 2. More examples of proven identities. Here we go. Practice means that you can pause your video and work each of these out before I do. Okay, so what I do, prove 1 over secant squared plus tan squared times cos squared equals 1. So I go to the left side, which is 1 over secant squared plus tan squared cos squared. That's the left side of the equation, and the right side is equal to 1. So what we do, we have to take one of the sides and work them down completely until we get the other side. So in this case, the more complicated side is the left, so let's work on that. 1 over secant squared, and secant is the reciprocal of cos, so 1 over secant squared is cos squared. Tan is sine squared over cos squared times cos squared. So what I did, I changed secant and tan and cosecants after there to sine and coses. Now I'll do PEMDAS. I have to multiply before I add. So I'll leave cos squared theta there. And when you're multiplying fractions, you cancel from bottom to top, numerator to denominator. So that gives you sine squared. And cos squared plus sine squared is equal to 1. And the right side is 1, the left side is 1. Since the left side equals the right side, it is an identity. So you can discuss with your teacher if he wishes to write the statement out. Number 2, prove that cosecant theta times sine theta plus cos theta equals 1 plus cot theta. So we have a choice to make. But before we do that choice, let's write down the left-hand side. There's the left-hand side, and this is the right-hand side. So which one should we change? Looks like this is the whatever. But whatever one you pick, if you were doing it on a quiz or homework, you would pick one of them. And if you can't get to this side here, or if you start here, can you get to this one? If you can't, then what I do is that when I work one of these down, if I can't go any further, then on a sheet of paper, I work the other one down until I get till they're equal, and then I reverse it, and I'll show you what I mean. Let's take the left side and go 1 over cosecant is reciprocal of sine. C is an S. Sine theta, cos theta. Remember now, I'm not touching this side. And so, and we notice we had brackets, but we can't add sine and cos, so I have to multiply. So 1 over sine times sine is sine theta over sine theta. And 1 over sine times cos is cos over sine. And when I multiply, now I'm going to add, but I can simplify this fraction here. So 1 over sine is 1, and cos over sine is cot. And exactly, everything worked out. So I picked the right side to work down, so there's no hassles. So since, let's write down, since the left side equals the right side, it is an identity. Okay. Okay, that's one page done. Let's try some more. And the more practice you do, I found with identities when I was going through as a student, the more you do, the better you get, and the more tricks you will find how to handle them. And prove that tan plus cot equals cosecant times secant. So the left side is tan theta plus cot theta. And the right side is cosecant times secant. And again, the more complicated side probably would be tan and cot plus cot. And so let's pick a side. I'm going to pick this side because of the plus sign. That's more complicated. Easier to work through. Probably let's see what happens. Tan is sine over cos. Cot is cos over sine. And because we're adding fractions, we need a common denominator, and the common denominator is cos times sine. So I'll multiply the first fraction by sine theta over sine theta, and I'll multiply the second fraction by cos over cos. And notice when I do that, this denominator here is sine cos. Sine times sine is sine squared. And we multiply here, we have sine times cos is sine cos. So notice the two denominators are the same. Cos times cos is cos squared. Because I have the two denominators the same, I will write down the denominator and add up the numerators. And I can't combine them because they're not like terms. But I know that sine squared plus cos squared is 1. And if now what happens, you have to recognize that. Let's say you're now stuck, and you say, well, pretend what you do now. You take this other side right here. Pretend that I'm working on a extra sheet of paper. So I write this down on the extra sheet of paper, and I work this down. So cosecant is 1 over sine. Secant is 1 over cos. 1 times 1 is 1. And I get sine theta cos theta. Now you notice that this side, they're both equal. But this is on a sheet of paper. You're doing this somewhere else. So when you do, then this is the same as this. So watch. You take this step and you put it here. And then you take this step and you put it here. What we're doing is reversing it. So remember now, that you're not allowed to do this unless your teacher allows you to go down to here and here. If your teacher allows you to do both of them, as far as this, and say, since the left side is right side is an identity, okay. But most teachers doing identities don't want you to work the two sides. They only want you to work one. So on a sheet of paper, you write this down, work it out, and then when you get to where you want, you reverse the step. So this step, that's right here, put it right here, and this step goes right here. So it makes sense that 1 over sine times 1 over cos is this. So you broke it up into one fraction into a multiplication, and then you change 1 over sine to cosecant, 1 over cos to secant. And since the left side equals the right side, it is an identity. So that's the little trick. When I get stuck, I go to the other side and work it down until they become the same, and then I roll the steps underneath. Let's try more and see what happens. Number 4, prove 1 plus tan theta over secant theta is equal to cos theta plus sine theta. And again, we have the left side, which is 1 plus tan over secant. They're all thetas. And the right side is cos plus sine. So the decision is cos plus sine can't be added. So this is the side that you would work down. So 1 over tan is 1 plus Tan is sine over cos. Sine theta over cos theta. Secant is 1 over cos. Okay, notice this is... So, what I do, is that I simplify. I can do this two ways. I have a complex fraction, so I can multiply by the LCD. If I multiply the top and the bottom by the common denominator, it cancels out all the fractions. Or there's another way that we can do it. We can also simplify the top to a fraction. The bottom is already a fraction, then multiply by the reciprocal. So there's two choices here. What I'll do choice 1. Choice 1, I'm going to multiply by the LCD. The LCD for top and bottom is cos theta. So I'm going to multiply cos theta by each term. So I'm multiplying each part of the expression by cos theta. So the LCD is cos theta for top and bottom. So cos theta times 1 is cos theta. Cos cancels out and you get a sine. Cos cancels out 1, 1, you get a sine. Cos times 1 over cos. Cos is cancelled out and you get a 1. And that becomes cos theta plus sine theta. So that's one way to do it. And since the left side, I'll make that statement. That's one way. But let's do it another way. Let's do it because there's two ways to do it. So I always like to show you different ways. But on a quiz, you would select one of these methods. And the other way to go would be to make the top a fraction. So make 1 as cos theta over cos theta. So remember now, I'm making this a fraction. I'm simplifying the numerator, this numerator here, to a fraction. So I'm changing 1 to cos over cos because cos is the denominator of this fraction. And that makes it, because they're the same denominators, I have a cos. And now I'm going to add these. All over 1 over cos. So I have a fraction on the top, fraction on the bottom. As a result, if we have two dividing with fractions, when you divide with fractions, then you multiply. These are two fractions, so you multiply by the reciprocal of the denominator. So this is a fraction, which is right here, multiplied by the reciprocal of 1 over cos is cos over 1. And they cancel, 1, 1. So that gives me cos theta plus sine theta over 1, which is cos theta plus sine theta. So I've done it two ways for you. And notice I didn't touch this side. This was the best side to convert, to change. Again, since the left side equals the right side, it is an identity. And I always like to make this statement. My students were doing proofs, I would have them write this statement out. But check with your teacher. Okay, here we go. Another one to do. So, again, we go with left side is cosecant theta, subtract cot theta over secant theta, and the right side is sine. So it looks like we're going to change this one. So cosecant is 1 over sine minus cot is cos over sine. Secant is 1 over cos. And before I do anything, I'm going to simplify this fraction here because we're dividing. So I'm going to go 1 over sine Notice PEMDAS, we have to do the division before we do the subtraction. So this is cos theta over sine times the reciprocal, which is cos theta over 1. Now we multiply, and that gives us 1 over sine. We can't do anything with that. We have to multiply these, so cos theta times cos theta is cos squared theta over sine. Notice we have two fractions with the same denominator, so I'll write the denominator sine theta down. So that's 1 minus cos theta, and 1 minus cos theta is 1 minus cos squared theta, sine squared theta. And sine squared divided by sine is sine. And left side equals right side. So since left side equals right side, it is an identity. And notice, you do one step at a time. You should be able to go from one step to the next to see the changes, and there should be a change. So one step at a time. Don't do 2 or 3 steps in one. I do one at a time. And the last one to do, simplify. Prove, as you can see, all of these. So I'm going to go left side is cos theta over there it is. And the right hand side is cos theta So again, which one are we going to do? So this is the case where you would pick one of the sides and work it down. And if you get stuck, then on a sheet of paper, you take the other side and work it down. So which one do we want to do? Well, it makes no difference. It looks like this one here got a plus. This one here is not bad. So 1 plus sine times 1 minus sine, I recognize that when I multiply as 1 minus sine squared. And 1 minus sine squared becomes cos squared. And cos over cos squared is 1 over cos. So this is going to, I'm looking. So I think what I'm going to do is work this side right here. Let's work the right side. So we got cos, because the rule of thumb that I follow is I change tan, cot, secant, and cosecant to cos and sine and work everything out in cos and sines. So tan squared is sine squared over cos squared times cos. Now I have to multiply these two. So cos cancels. So cos on the top cancels into cos squared on the bottom. So that gives me sine squared over cos. And the common denominator, there's only one denominator, which is cos. So cos, we put it over 1, so I can put a cos here. So 1 into cos goes cos. Cos theta times cos theta is cos squared theta. In other words, you could multiply this one by cos over cos. If you multiply this fraction by cos over cos, you will get this. But cos squared over cos simplifies to cos. So multiply by cos over cos, or 1 into cos goes cos. Cos times cos is cos squared. Remember when I was saying cos, I mean cos theta, right? And we have the same denominator, which is cosine or cos. And we have cos squared plus sine squared. And cos squared plus sine squared is 1. So this side becomes, if you did pick this side and work it down, you have 1 over cos. Now, you're not supposed to work this one down to get the 1 over cos. So what you do, pretend on a sheet of scrap paper, you would write this down. So I'm going to pretend that this is on a sheet of paper, and I'm going to work it to see what happens. So cos. When I multiply these two, I'm going to do FOIL now. That's 1 times 1 is 1. 1 times negative sine theta. Sine theta times 1. Negative times negative. Negative, positive times a negative is a negative. Sine times sine is sine squared. So that becomes cos theta all over. They cancel out. 1 and 1 minus sine squared is cos squared, which is cos cancels. Cos and the cos goes 1. Cos and the cos squared goes cos. So that becomes 1 over cosine, which is what's here. So if this is the one you started, which we did, remember now, this is on a sheet of paper. So what you do now, you reverse. So you take this step and you put it right here. Take this step, which is cos theta over cos squared theta. Then you take this step and you put it here. Then you take this step and you put it here. And this, well, I don't need to do this step because this is already, I can go 1 plus sine, 1 minus sine. Why? Because if I got cos squared becomes 1 minus sine squared, 1 minus sine squared is factored into 1 plus sine, 1 minus sine. And then what happens? This side is this side. So I didn't need, remember, I'm going to cover it up. I'm going to cover it up with a sheet of paper that I just did. Here we go. So if I cover this up, now that's what I did on my, what's underneath my paper is what I did over on the extra sheet of paper. So now look at the proof. I started with the right side, I worked it right down, and it makes sense. So now, pretend this is what's underneath my, that's what I did on my extra sheet of paper. Nobody's seen it, and now I just reverse the steps from my sheet of paper. Hopefully you see what I'm talking about. Since the left side equals the right side, it is an identity. So that's the skill or the trick that you have to do to work these. You work one side to get the other. When you get stuck, then you work the other one down on a sheet of paper, and when you get them the same, reverse the steps like I did, like I told you. Take this step and put it here. Take this step, put it here. Take this step and put it here, and we have it all done. Hopefully, the more practice that you do on identities, the better you are. And it's imperative that you have these unit on rational expressions done, simplifying rational expressions, because you're adding and subtracting, multiplying and dividing fractions. And if you like my video, click the like button, subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.